don't normally do. Anyways, here we go. We got to write the equation of a parabola from the description that they give us, which is the focus and directrix, and then move a sketch, or make a sketch showing the parabola and focus and directrix. So we're going to use Desmos for that, but we're gonna plug this stuff in. So let me guide you guys through this, okay? Because this is exactly how you're going to do your homework. So when you see a problem where they give you a focus and directrix, first and foremost, you're going to look at these two examples. Remember that P is the value that isn't 0. So this is P comma 0. And I'm going to jump to problem number 4. This is 0 comma P. So in this problem, P equals -1/2. And or it is a y value. So that's the thing. For an x value P, we do one thing. For a y value P, we do another. Okay? So these are x comma y values, but with regards to formulas and how we graph it and all that stuff, we're going to label them as P. The other one is going to be 0 always. Okay? Now, they give us a clue when they give us the directrix. The directrix is going to have x equals -2. So I'm gonna open up Desmos real quick, and we're gonna graph that, and then we're gonna look at the table of values. Okay, so this is the directrix. All right, so that means that my parabola is going to be horizontal this way, probably, right? It has to be, because the focus is probably going to be over here on -2, right? Because it's going to be equidistant. So at the origin, because this is 2 units this way, my focus is going to be at -2. In fact, what is that value? It's -2 comma 0. This is where my focus is going to be. They tell us that's where my focus is going to be. So I'm going to graph that. -2 comma 0. Okay. And we'll just label that. How come it didn't? Oh, because I hit the wrong button. That's why. Comma 0. I hit the period instead. And we'll label this as our focus. Okay. So that means that parabola is going to come through the origin, and it's going to be horizontal. Now, if you don't know that off the top of your head, what we need to do is just go back a couple slides. So if I go back to this table, this is, for every homework problem you're going to do, you're going to look at this. In this particular case, we're given a p-value of x. That tells us that it's horizontal. In fact, I'm going to copy and paste this real quick, just so you guys can see it. So I'm only going to work with this stuff. This is the information that I need, okay? And that's what I'm going to use to finish this problem. And I'll make it a little smaller, but I'm just going to paste that right here. But you guys should be looking at this information as you do your homework, okay? So this is for problem number 3. All right? So now my equation then is going to be y equals 4px, and my directrix is going to be negative p. So I'm going to label this P is +2. Oh, you know what? I screwed it up already. Look at this. Do you see what Mr. Adams did? I got confused. I put the -2 over here and the 2 over here, but that's okay. We can fix it. So this is -2. I would have caught it eventually as I started to go through this. This is -2, and this is +2. Okay? So it's going to open this way to the right. My bad. So let's do this work, though. So that means that P is equal to 2, and that makes sense because this is always going to be the opposite. In other words, x equals negative P. Oh, no, not negative P. It just equals -P. So because it equals -P, my directrix, x equals -2. That's where that comes from, okay? We know that when P is positive, this occurs when P is greater than 0. I forgot to put that in there. This occurs when P is less than 0. All right? it's going to open to the right. So if I were to sketch this out real quick, my directrix is going to go through -2. I don't know what color I use. We'll use red. So my directrix is going to be x equals -2, which is going to be a vertical line at -2. X equals -2. My focus is going to be at +2, 2 comma +2. That's not really equal distance, so let me get rid of that. Make it look a little better. And then I know that my parabola is going to kind of do one of these things. Go through the origin. Okay. Does that make sense? And that's basically it. So the last thing I got to do is write the equation. Well, I've got y equals 4px. So y squared equals 4px. In other words, y squared equals 4, what's p? 2 times x. Or y squared is equal to 8x. Okay? Now, I'm going to show you how to graph this on the actual TI calculator and the Desmos. So, let's do it on Desmos first. So the next thing I'm going to do is you could graph it just how you see it. Y squared is equal to 8x, right? And wabam with the bacon sizzle, that's what it looks like. So I'm gonna sketch this real quick, or screenshot this, so we could see it. So this is what it actually looks like in Desmos, and I'll make it smaller. But that's it. Okay, that's the graph. Now let me show you how to do this on the graphing calculator. So as I pull up my graphing calculator, we're going to toss this over to the side as soon as it loads up. To do this on the graphing calculator, we got to split it up a little bit. Okay? So let me minimize this. I could do this on the graphing calculator. I just have to split it up. This right now is not a function. I can make it a function because if I say, let me change the color here. If I say y squared equals 8x, and I go the square root of y squared, then I have to take the square root of the other side. Now, when you take the square root of this, you get y equals, whenever we take the square root, what's the one thing we have to remember? Plus or minus 8x, the square root of 8x. So now what that means is that's going to give me two equations. One equation will be y equals the positive square root of 8x, and y equals the negative square root of 8x. And this is how you have to graph all these sideways horizontal parabolas. So if I do this, if I go into y equals, okay, and I'm going to clear this out. Let me move this over here temporarily. And I'm going to say the positive or principal square root of 8 times x. And then I go here and I say the negative square root of 8x. Okay. And then I'm going to hit zoom standard. There it is. Same thing, right? Now, unfortunately, on this one, I can't graph the x equals 2 because this calculator only graphs functions. I mean, there's a workaround, but let's just check the parabola, okay? So I'm going to take a screenshot of that as well. And so that way, if you're taking the SAT test, which I think just about all of you will, maybe one or two won't, but this is what it looks like on the TI calculator, okay? And let me label this here. So this is this right here is going to be the y equals the square root of 8x. And make sure that you kind of put y equals negative square root of 8x. Make sure you get that x under the square root symbol. Okay. And that's it. That's how you graph it on the TI calculator. Okay. Now for number 4, you basically do the same thing. Yes, question?
Yeah, how do we get 4 for yx squared?
4 for yx squared. You mean this formula here?
Yeah.
We did that on the first problem. So to find, that was the very first thing we did, is we took this example. That's a good question. You're basically asking where does the formula come from? Well, we derived the formula. That was the first example, and it's okay if you don't remember that. But basically, we do a bunch of math using the distance formula. So the distance from here to here is the same as the distance from here to here. So if you have a line that goes from the directrix straight to the parabola such that it forms a 90-degree angle with the directrix, that distance from the parabola to the directrix is the same as the distance of the line segment from the parabola to the focus. And so we used the distance formula to calculate the distance here. And then we also used the distance formula to calculate the distance from here. And when you set those two distance formulas together, in other words, this is one of the distance formulas, this is the other. When you set those two distance formulas together, you end up with this. And algebraically, when we finish the whole thing, we get y squared equals 4px. That's where the 4 comes. It's just the formula, and it's from the derivation. It will always be 4px or 4py, depending on how you do that. And so I'm glad that you brought that up. Now, the only thing that changes, because if you notice on the other one, we actually have the y value for p. And so what that means is that we're going to use this column of information. And let me try to, if I have room, I'm going to try to put this in there too. And so if you flip that, if you flip this derivation that we did the first time, the very first thing we do, if I take this parabola and I flip it to where it's a vertical parabola like this, your formula here, the only thing that changes is you flip-flop the x and the y. In other words, this information here, way over here, the formula changes to x squared equals 4py. So we just flip-flop it. So it's x squared equals 4py. Does that make sense? Well, it might not make sense, but it's a lot to soak in, but that's where the formula comes from. So we're going to do the same thing here, all right? When I do this one, though, so then to sketch and graph and all this stuff, y equals 1/2, that's a horizontal line, right? That graphs like this. And I have a p value, which is a y value, that's equal to negative 1/2, right? So that means the directrix in this case would be y equals negative p. So when I say y equals negative p, I don't know why I keep making it one big thing. I'm going to say y equals negative 1/2, because I'm getting a step ahead of myself. So y equals positive 1/2. Now they gave that to us, but I want to show you guys that because in some of your homework problems, they will ask you. You should be able to do almost everything from this, but that's why I'm going through and showing you stuff. So then I know what p is, right? And so now to find the equation of the line, I'm just going to use this information. So I'm going to say x squared is equal to 4 times p, but p is equal to negative 1/2, and times y. So x squared is equal to negative 8y. So that's our equation. And we're gonna actually try to graph this by hand, and then I'm gonna show. Oh no. Okay, good. Whoo, that was a close one. We're gonna try to graph this one by hand. So I'm gonna and then we'll double check it. So I'm gonna write this over here. Make sure I get enough spaces. So this is my y-axis, and then this is my x-axis. And we'll think of this as 1, we'll think of this as 2, and I'm going to zoom in a little bit because I tend to write big. And so this would be like 3, this would be like 4, 5, this would be 1, this would be 2. We'll call this negative 1, negative 2. Okay, so our focus is at 0, negative 1/2, right? So our focus is 0, negative 1/2. So let's graph that. Our focus is 0, negative 1/2, right here, right? I should probably identify this as negative 1. This is negative 2. Okay, and then my horizontal line, remember the vertex is going to go through the origin, but they give us the directrix, so we're going to say y equals negative 1/2. What color did I do that in? Red. So y equals negative 1/2 is going to be a horizontal line that kind of comes, it's going to be parallel to the x-axis because it's a horizontal line, and it's going to cross through y equals 1/2. So this is y equals 1/2. That's the directrix. And this down here is my focus. Okay. And then my parabola, I could plug in x and y values and get a table of values. So let's plug in some values for y. But before we do that, you don't realize this. This is actually a function. Because it's a function because I know that when I sketch this, this is going to go through the origin like this, and my parabola is going to go through the origin. So that'll pass a vertical line test. Okay? So if I wanted to graph this by hand, I could just plug in some numbers and see what I get. I'm not going to do that right now because it'll take a lot of time, but I encourage you to try that and see if those points are on the graph. But anyways, I can graph this in the graphing calculator, but how do we graph things in the graphing calculator? Well, let's do it in Desmos first. So the first thing I'm going to do is I'm going to come in here, and this is negative 8y, right? And this is going to be x squared. And then my these are flip-flopped. This is going to be 0, negative 1 divided by 2. And then this is going to be y equals 1/2. Oops, 2. Okay, so that's pretty accurate, right? That's basically what Mr. Adams just sketched by hand. Well, I didn't do the parabola yet, but this is basically what Mr. Adams sketched by hand. So let's put that on here somewhere. So that's right. And then I could pick a point and graph it. So, but I'm going to take this and make it, in order to graph it in my graphing calculator, I need to make this, I got to solve for y, right? Because my calculator is going to say y1, y2, and all that stuff, right? So I've got to solve for y. So how do I solve for y? I just divide both sides by -8, right? So if I divide both sides by -8, I'll end up with y equals x squared divided by -8. That's it. So I'm going to pull out my handy dandy calculator, go into y equals, clear this out, clear this out. Now, because both the directrix and the parabola are functions, because we rotated it, right? I can graph both those. So y equals 1 divided by 2. That's our directrix. And then we said, and remember, if I want to enter in a fraction, I just go to math, go to the fraction menu, hit this. I'm going to put my x squared in the top, and then -8 on the bottom. And now when I graph these, that's what I get. Now I'm going to zoom in a little bit. Actually, let's just do the window. I'm going to do -2 to 2. And then -2 to 2 on the y-axis as well. And we'll graph that. And so if I take a picture of that, that's the same thing that we have in Desmos. Okay. Any questions on that? So I want to show you how to do it multiple ways. It's amazing what you could do with the graphing calculator if you feel comfortable with manipulating the algebra. So it stretched a little bit because your TI calculator, I don't know, the screens, they could do a better job with the screens and making it, the x-axis always seems to be stretched a little bit. But the reason I plugged it in the TI calculator is I wanted to show you this. So for your table of values, it's not always easy. And let me go in here and turn off the Y1. And we'll go back and see it. This is what I wanted you to see. It's not going to be easy to find values that are going to work out to regular numbers, but 8 and -8 work, right? In other words, when I plug in 8 for x, I'm going to get -8 for y. And that makes sense, kind of, doesn't it? Yeah. And I bet you get the same thing for -8. Yeah, 8 and -8. And where that comes from, so we'll plug those into the formula. So if I say, if I let x equal, so let me kind of sketch this. 8 and -8 would be like way out here. 2, 4, 6, 7, 8. It'd be like way out here. And then this one would be like way out here. 3, 4, 5, 6, 7. Well, it'd be over here. 1, 2, 3, 4, 5, 6, 7, 8. So it'd actually be here. I'm actually going to graph it out. And then over here, here's a trick too for graphing parabolas. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8, -8. This is -8, -8. And remember, this is an x value, and this is a y value. This is an x value, and this is a y value. So if I say x squared equals -8 times y, in other words, I'm going to get -8 squared. What does that equal? 64. And then I have -8 times my y value, which is -8. They both equal 84. Same thing over here. If I say 8 squared equals -8 times -8, they both equal 64. So we know that that works, right? Now you could plug in 1 and 2, but I just wanted to show you kind of a quick, easy way, because when you take the SAT, you only got about a minute per question. And so if I were to graph this, We'll graph it in blue, I guess. It's going to kind of look like this. My parabola is going to curve. I'll do the best that I can on the tablet. This way. Oh no, it's actually going to go through the origin, so it's going to kind of go like this. And then perfectly symmetrical. Okay, so that's what it would look like. Any questions on that? How do you guys feel about that? So when you go to do the homework, the only thing you got to do is if they give you 0, p on these particular types of problems, or p, 0, the first decision you have to make is it going to be horizontal or is it going to be vertical? And then from there, you just use this. You make a decision. Am I going to use this column or am I going to use this column? That's all you have to decide. Which column am I going to use? Am I going to use this one or this one? And then just go down the list of all the things and make sure they match up. Okay?